Uh, in yesterday's class, we studied about the stresses in the thin cylinder. Now we will continue from there and start studying about the strain in these type of cylinder. We will see what are different types of strain that can occur in these cylinders and how we can calculate these change in length or change in volume or change in diameter of thin cylinder due to the stresses or due to the internal pressure that is acting on the walls or the side walls or the end walls of the cylinder. So first we are going to study about the change in length. Now, if you look into this figure over here, we have these longitudinal stress. Now, as I explained yesterday, that these stresses are occurring on the circumference or the thickness of the cross section that we cut perpendicular to the longitudinal section of the cylindrical element. Now, if you see that these particular stresses, what are they doing? They are acting in the opposite direction and tend to elongate this cylindrical element, right? So due to these stresses, due to longitudinal stresses, we will have either an increase or decrease in length. So that means that the strain which is being produced, if I call the longitudinal strain as epsilon L, then this strain will be responsible for the increase or decrease in the length of cylindrical element, right? So coming on to this one, I want to compute the longitudinal change in length. For example, it is quite obvious that that we do need to calculate this particular factor uh, depending on the pressure so that we can incorporate that in our design. So for that, we need to consider the change in length, we need to consider the longitudinal strain. And as you are aware, I will just solve this derivation over here. We know that change in length, or if I want to represent the strain, that is equal to change in length over original length, right? So what strain should I substitute at this point for the case of length? Anyone? यहाँ पे कौन सी strain आनी चाहिए?
Longitudinal, sir.
Longitudinal strain, of course. But also we have learned from some of our basic principle that when strain is acting in one direction, for example, when there is, or you can say that when stress is acting in one direction, it also produces some minor strain in other two mutually perpendicular direction, right? So strain in one direction produces माइनर स्ट्रेन, और इन दोनों को कोरिलेट कैसे करते हैं, कोई बता सकते हैं, कोई फैक्टर है?
Poisson ratio, sir.
यस, इन अदर टू परपेंडिकुलर डायरेक्शंस. अब इस फिगर में देखें आप, हमारे पास कितनी टाइप्स की स्ट्रेसेस होती हैं. एक longitudinal stress we have, then the other one is this hoop stress, and the third one is this radial stress. So what will happen when there is a longitudinal strain? Due to this longitudinal stress, then some minor strain will also be produced in this direction of hoop stress, which I can call as epsilon h, and also there will be some strain in the radial direction, or there will be some radial strain. And what happens due to this case, that if your original strain is, let's say, in the longitudinal direction epsilon L, then due to this transverse or minute strain in the other direction, it reduces in magnitude by a factor nu into the strain in the other direction. And the third strain we have is epsilon r. So this will be your actual strain that will be occurring in the longitudinal direction. Okay. So this will be your actual strain. But what happens, as we discussed yesterday, that the radial stresses or sigma r is quite small. So what will happen that when since the stress is very small, the strain will also be very small. So we will by default ignore this radial strain from our derivation as well as in our calculation, since it doesn't make much of a difference, and we will consider these two stresses. So over here, since I have to substitute the longitudinal strain, because as I explained that the change in length is due to this longitudinal strain, and over here I have write down the expression for longitudinal strain. So that will be epsilon L minus nu into hoop strain, which is also the circumferential strain, and that will be equal to change in length over original length. And if I further simplify this one, I will get epsilon L is equal to, or change in length equals to, minus nu into epsilon H into original length. Now this is the same expression which is written over here, that for the change in length. Now as we know that this epsilon L is also equal to sigma L over E, and if I substitute this factor into this equation, I will get change in length equal to sigma L over E minus nu sigma H over E into original length. Now this is one expression in terms of stresses. Why I have written over here in terms of stresses? Because we have some direct formulation to calculate the stresses, which we calculated or derived in the yesterday's class. So this is the same expression in which I have taken this modulus of elasticity as common, and for change in length we have this one. Now if I substitute the values of this longitudinal stress into this equation, which was this one PD over 4T, and for hoop stress our expression was PD over 2T, and further on simplification we will finally get this particular expression for change in length. Now you can see in this expression we have correlated the change in length with the internal stress, uh, which is the factor of the fluid that is present in the cylindrical element, and all other factors are the material properties. For example, this length, this nu, this diameter, thickness, and modulus of elasticity are material properties. So if someone asks us that if I place this fluid in the cylindrical element and the material properties or the dimension of the cylinder are such, can you report what will be change in length? So we can do that by using this expression, and then we have to see the codes that how much change in length is allowable for different type of material. For example, it is the case that in some cases it says that you can have maximum change in length up to 2 millimeters in that particular element. So if this change is coming out to be more than 2 millimeters, for example 5 millimeters, then that means that we have to change something. Either we have to increase the length or change the diameter so that we fall in the allowable limit for this allowable limit for a particular fluid, for a, or we can make our cylindrical element safe to carry a particular uh, fluid. So this is about change in length. Any question about this one? Now in the same way, we have a small derivation for change in diameter. One thing we have done is that was change in length. Now for change in diameter, coming back onto our original figure, now you can see in this one, now this hoop stress is acting in the vertical direction. So what will it do? When this stress will be occurring, it will try to extend the elongate the diameter. Either it can elongate depending on the direction of forces, or the hoop stress will increase, cause an increase or decrease in the diameter of the cylinder. Just like as we discussed just now, that the longitudinal stress is causing an increase or decrease in the length, as you can see from the figure, and similarly this hoop stress is causing an increase or decrease in the diameter. And in the same way, just like we did for the case of hoop stress, we can also derive one expression to numerically calculate the change in diameter based on the internal stresses and the material properties. For example, we know that change in diameter or diametric strain will be equal to change in diameter over original diameter. Now, what should I substitute over here in place of this diametric strain? By the way, can you see the whiteboard?
No, sir.
No, sir.
I should ask this. Can you see it now?
No, sir.
No, sir.
Yes,
Okay.
sir. Yes, sir.
Is it the case with everyone? I believe you should be seeing the whiteboard now.
Yes, sir. अब देख सकते हैं.
So, if I write an expression for diametric strain, that will be equal to delta D over T. And can anyone tell me what should I substitute in place of this diametric strain over here? Or I can call it as epsilon D. What will be the expression for diametric strain in terms of radial, hoop, or longitudinal stress? Stress or strain?
Sir, hoop stress multiplied by new.
So hoop stress is the major, hoop strain will be the major strain that is causing this diametric strain. So that will be epsilon h, and the other one that will tend to reduce its effect will be the strain in other two mutually perpendicular direction. So obviously we are neglecting the radial strain, same reason that the magnitude is very small, and we are considering the longitudinal strain in this one as well. So that will be delta D over D. Again, if I simplify this one to calculate the change in diameter, that will come out to be epsilon h minus nu epsilon L into D. Again, if I represent this strain in terms of stresses, that will give me an expression for 1 over E that will turn out to be hoop stress. Then I will have nu into longitudinal stress into diameter. And further on simplification, or when I substitute the values of this hoop strain, I can show it over here. In this figure, you can see that we have derived up to this point, and when I substitute the values of this hoop stress, that will be PD over 4T or 2T, sorry, and for the longitudinal stress, I have this expression that is PD over 4T, and when I simplify this one, I will get this particular expression for the change in diameter based on, again, the internal stresses and the material properties. So this is how you calculate the change in strength. The important thing, change in diameter, sorry. The important thing that you should remember, because these derivations are not complicated, you should remember this is very important diagram. If you have this diagram, you can easily figure out that which of the stress is causing the change in diameter, which stress is causing the change in length, and all such factors. And using those correlation between stresses and strain, you can directly calculate the change in diameter or change in length. Now coming back on to the third one, can you tell me that Is there any
सर
question?
हमने ये लॉन्गिट्यूडनल स्ट्रेन जो है सर ये माइनस क्यों किया है अभी?
माइनस क्या है?
सर लॉन्गिट्यूडनल स्ट्रेन हमने क्यों माइनस किया हुप स्ट्रेन से?
हुप स्ट्रेस के साथ माइनस क्यों है?
सर हुप स्ट्रेन जो है ना उनसे हमने
I can't.
लॉन्गिट्यूडनल स्ट्रेन
If someone else can understand his voice, I can't hear him properly.
सर ये कह रहा है कि हुप स्ट्रेन से हमने लॉन्गिट्यूडनल स्ट्रेन क्यों माइनस किया?
माइनस क्यों किया? देखो जब ना आपके पास, आपने ये पढ़ा होगा शायद, जब भी आपके पास स्ट्रेसेस लगती है ना, फॉर एग्जांपल अगर ये बॉडी है, ठीक है, इसमें कोई भी स्ट्रेस लगेगी, फॉर एग्जांपल अगर मैं कहता हूँ कि सिर्फ सिग्मा एल जो है वो इसमें एक्ट कर रही हो, या ये लॉन्गिट्यूडनल स्ट्रेस एक्ट कर रही है, तो इसकी वजह से इस डायरेक्शन में तो स्ट्रेस प्रोड्यूस या स्ट्रेन प्रोड्यूस होती ही होती है, ठीक है, यानी कि लॉन्गिट्यूडनल स्ट्रेन तो प्रोड्यूस होगी, लेकिन इसकी वजह से क्या होता है कि जो भी परपेंडिकुलर या जो भी कोई भी अदर डायरेक्शन है उसके अंदर भी कोई ना कोई माइनर स्ट्रेस प्रोड्यूस हो जाती है। फॉर एग्जांपल ड्यू टू सिग्मा एल हमारे पास जो भी इसके अलावा जो भी डायरेक्शन है, फॉर एग्जांपल यहाँ पे भी कोई हो सकती है, यहाँ पे भी हो सकती है, तो वहाँ भी कुछ ना कुछ स्ट्रेसेस प्रोड्यूस हो जाती है, माइनर स्ट्रेसेस, दे आर नॉट वेरी लार्ज इन मैग्नीट्यूड, लेकिन उनका कोई ना कोई इम्पैक्ट होता है। अब उस माइनस स्ट्रेसेस प्रोड्यूस होने की वजह से क्या होती है कि अगर ये सिग्मा एल ओरिजिनली 20 एक्ट कर रही थी, तो इसकी वजह से लेट सपोज ये स्ट्रेन 0.001 प्रोड्यूस हुई है, तो इस 20 की वजह से यहाँ पे भी कोई 1 मेगापास्कल की लेट सपोज स्ट्रेस प्रोड्यूस हो गई है। अब इस 1 मेगापास्कल की वजह से भी कुछ ना कुछ 0.0001 लेट सपोज स्ट्रेन प्रोड्यूस हो गई है। तो ये जो ओरिजिनल स्ट्रेन यानी एप्सिलॉन एल थी ना, ये इसकी एक्चुअल वैल्यू नहीं रहती, इसमें कोई ना कोई स्मॉल डिफरेंस आ जाता है, यानी ये कम हो जाती है अपनी एक्चुअल वैल्यू से। क्यों? क्योंकि दूसरी डायरेक्शन में भी प्रोड्यूस हो रही है, वो उस डायरेक्शन में भी सिग्मा एल की वजह से एलोंगेशन प्रोड्यूस हो जाती है, तो इसका ये पूरा इम्पैक्ट नहीं आता एक साइड के ऊपर। तो उसको आपने क्वांटिफाई कैसे करना है, वो आपने पढ़ा होगा रिलेशनशिप दैट एप्सिलॉन एल, जो अगर ओरिजिनल एप्सिलॉन एल हो या लॉन्गिट्यूडनल स्ट्रेन हो, तो वो एक्चुअल में क्या होती है कि कुछ ना कुछ लेस होती है ओरिजिनल वैल्यू से, और वो लेस कितनी होती है, वो पॉइजन रेशियो टाइम्स स्ट्रेन इन दी परपेंडिकुलर डायरेक्शन होती है, राइट? आपने इस तरह का कुछ रिलेशन पढ़ा होगा पॉइजन रेशियो का। तो ये रिलेशन क्या शो कर रहा है? ये रिलेशन इनके दरमियान रेशियो शो कर रहा है कि ये वाली स्ट्रेस एप्सिलॉन एल कितने टाइम्स लेस है कंपेयर टू एप्सिलॉन एच, यानी म्यूचुअली परपेंडिकुलर स्ट्रेन्स के दरमियान कोरिलेशन, राइट?
ओके सर थैंक यू।
So coming on to third thing, that is change in volume। अगर आपने change in volume कैलकुलेट करना हो तो उसके लिए कौन सी स्ट्रेन आप लोगे?
रेडियल सर।
रेडियल स्ट्रेन से तो कोई इतना खास इम्पैक्ट ही नहीं पड़ रहा होता है।
सर हुप लेंगे सर।
अच्छा, उसके लिए ना अब इसी तरह जैसे हमने लेंथ और डायमीटर का कोरिलेशन तो एक कैलकुलेट कर दिया, ठीक है। अगर मैं कहूँ अब वॉल्यूमेट्रिक स्ट्रेन क्या होती है आपके पास, that is obviously the volumetric strain क्या होगा, that will cause change in volume over original volume। अब जो भी हमारे पास जो बाकी दो थे डायमेट्रिक या लॉन्गिट्यूडनल स्ट्रेन, उस केस में तो वी हैड डायरेक्ट रिलेशनशिप फॉर हुप स्ट्रेस और लॉन्गिट्यूडनल स्ट्रेसेस, तो वो हम डायरेक्टली सब्स्टिट्यूट कर लेते थे, लेकिन वी डोंट हैव डायरेक्ट रिलेशनशिप फॉर वॉल्यूमेट्रिक स्ट्रेस। तो इसके लिए we will move in a slight we will derive based on a slight different method। For example, अब उस केस में हम क्या करते थे, हमारे पास ये एक अननोन होता था डायमीटर या लेंथ, और उस अननोन के लिए हम एक रिलेशन बना देते थे। लेकिन यहाँ पे क्या इशू है कि वी हैव टू अननोन्स, डेल्टा वी भी अननोन है, एप्सिलॉन वी भी अननोन है, वी डोंट हैव एनी रिलेशनशिप फॉर दीज वन। तो हम इसमें थोड़ी सी डिफरेंट डेरिवेशन करेंगे टू गेट to solve first this delta v, and then we will substitute this delta v back into this equation and derive one relationship for change in volume, again based on these four parameters या जो भी मटेरियल प्रॉपर्टीज हैं उनकी बेस पे हम इसका भी एक कोरिलेशन बना लेंगे। सो अगर इफ आई राइट द एक्सप्रेशन फॉर चेंज इन वॉल्यूम, चेंज इन वॉल्यूम क्या होगा, क्या होता है, that is final volume minus original volume, right? This is what change in volume is. Simple concept. Now let's suppose I have the same cylindrical element, and if I want to write down the final volume कि जी इस पे stresses लगी हैं, उसकी वजह से strain produce हुआ है, और उस strain की वजह से उसका volume change हो गया है। तो अगर मैं ओरिजिनल डायमीटर आपके पास d है, ठीक है, and original length is L, and then change in diameter is delta D, and change in length is delta L, तो final volume का कोई मुझे एक्सप्रेशन बता सकते हैं कैसे लिखूं मैं in terms of diameter and length?
सर d प्लस वो होगा ना चेंज इन d।
तो अगर ओरिजिनल वॉल्यूम का एक्सप्रेशन लिखना हो, दैट इज पाई बाय 4 d स्क्वायर इनटू लेंथ, एरिया इनटू लेंथ इज वॉल्यूम, राइट? दैट इज ओरिजिनल वॉल्यूम। So if I want to write the expression for final volume, अब उससे क्या हुआ है कि उसका diameter भी increase हो गया और length भी increase हो गई है, तो that will be obviously d plus delta d square, and the original length was L, and change in length is delta L. So this will be the expression for final volume. Now if I simplify this one, I can get some expression of volume in terms of diameter and length. Over diameter or length, again material properties, and if I substitute this expression back into this equation, and then if I substitute this delta V into this equation, I may get one expression for change in volume in terms of these 5 factors which I have written over here. So let's just quickly conclude this derivation. Now if I simplify this one, I will get pi by 4. If I open this square, that will be d square plus delta d square plus 2d into delta d into length plus delta L. If I multiply these two terms, I will get pi by 4 d square L plus delta d square into length plus 2L d delta d plus d square delta L plus delta d whole square into delta L plus 2d delta d into delta L. So this is the simplified expression. Now in this expression, again these strains are very small in magnitude, and if I ignore the square terms for the change in length, for example, I can ignore this term because over here we have the square root of or square of change in length. I can ignore this term, and I can also ignore this term. What I will be left with is final volume equals to pi by 4 d square L plus 2LD delta d plus d square L. Sorry, this will be d square into delta L. So this will be my simplified expression for final volume. Now again, if I substitute this back into the formula for change in volume, which is final volume minus original volume, then I will get the following expression, that is pi by 4 d square L plus 2LD delta D plus D square delta L, and original volume is again pi by 4 D square into L. Again, these two terms are same but opposite in sign, so they will cancel out, and the change in volume will be 2LD delta D plus D square into delta L. So this is my simplified expression for
पाई
change.
बाय 4 भी तो आएगा, मल्टीप्लाई होगा सर पाई बाय 4 भी।
क्या है?
सर ये जो आपने चेंज इन वॉल्यूम निकाला है इसके साथ पाई बाय 4 भी मल्टीप्लाई होगा।
Yes, we will do. So we will have this is the expression for change in volume. Now if I substitute this equation back into my original equation for volumetric strain, that was epsilon V equals to delta V over original volume. So I will get pi by 4 2LD delta D plus pi by 4 D square delta L, and in the denominator I will have pi by 4 D square L, and further epsilon V will be, now this D, this pi by 4 will cancel out with this one, this D will cancel this one, so first expression will be 2 times delta D over D, and the second expression will be delta L over L. For example, over here this D square will cancel out this one, so I will be left with this particular expression. So this is one expression for volumetric strain. Now if I look into this one, what is my delta D over D? Can I say that this is again
change in diameter, sir.
epsilon H, because hoop strain is causing strain is equal to delta D over D, and in the same way this change in length is caused by longitudinal strain, so I can write over here as epsilon L. So this is my expression for epsilon V and epsilon H. Now I know direct correlation which we have just derived for these epsilon H and epsilon L. Let's come back onto this one. Now if you look into this slide, this was the equation that we just derived, and I have the direct relationship for epsilon H. Now if I substitute this relationship of epsilon H and epsilon L into this equation, I will have this equation which I have written over here, that is PD over 4 TE into 2 minus nu, and for epsilon L I have this one, PD over 4 TE 1 minus 2 nu, which I just derived over here. Okay, over here I have written this expression. I have the correlation for delta D. For example, delta D I know is PD over 4 TE into 2 minus nu into D. Just wait a moment, I think there is some mistake in this one. Okay. Actually, this relationship is for not for epsilon H. In fact, it is for delta D. Just make this correction in the slides. And this one is for delta D. Yes. This relationship is for delta D, and this relationship over here is for delta L. Now, if I substitute this relationship into this equation, into my original equation of delta D, then this D factor will cancel out with this one, and this L factor will cancel out with this one, and I will be left with a one expression for change in volume or volumetric strain, that is epsilon V equals to this one. And if I further simplify this one, I will get final expression as PD over 4 PE into 5 minus 4 mu. So this will be my final expression for volumetric strain in the cylindrical element. Now, if you want to calculate the change in volume, so you have first you can calculate this volumetric strain, and once you have volumetric strain, you have this simple expression that it is equal to change in volume into original volume, and you can make it like this one to calculate the change in volume. So just make some correction or write it somewhere that this expression is written wrong over here, and it is actually the expression for delta D or delta L. So this is your expression for volumetric strain. Now, any question about this derivation? So to sum it up, we have derived three equations for three types of strain. One for hoop strain, the other one for longitudinal, and the final one is for the volumetric strain. Now let's solve a simple question so that we can understand the application of these correlations. So in this question, we have been provided with a cylindrical shell or cylindrical element having an internal diameter of 1 meter. The length is given to us as 3 meter and wall thickness is 12 millimeter. The internal pressure is given to us as 1.2 megapascals, and we have to figure out the longitudinal stress, the hoop stress, the change in diameter, that is delta D, change in length, change in volume, and modulus of elasticity is given to us as 200 kilopascal, and the Poisson ratio is given to us as 0.3. So first thing is this longitudinal stress, and we have the expression for longitudinal stress, that is PD over 4T. So the longitudinal stress is PD over 4T. Take 1 minute and give me the answer for these two. Hoop stress, we have the direct correlation as PD over 2T. Now take 1 minute and give me the answer of these longitudinal stress and hoop stresses.
Sir, 50 megapascal.
For longitudinal stress,
No, sir. For this hoop stress.
hoop stress. Anyone else? I think your answer is correct. So for hoop stress, if I substitute the values over here, the pressure is 1.2 megapascal. So I will keep the units same because megapascal is obviously Newton per millimeter square. Then the diameter is what? Internal diameter is given to us, that is 1000 millimeter, and then we have the thickness as 12 millimeter. So if I solve this one, I will get the hoop stress as 50 megapascal. What about longitudinal stress now? That would be simple. It will be half
So
of this.
25 megapascals. 25
So
megapascals.
that will be 25 megapascal. So this is the longitudinal stress. Now let's calculate this change in diameter. What will be delta D? I will write the expression over here. For delta D, we have this one, Pd over 4Te into 2 minus nu inverse. 2 minus nu into original diameter. This is your expression for delta D. And if I write the expression for change in length, that will be Pd over 4Te 1 minus 2 nu into original length. So these are your expression for change in diameter and change in length. Now give me the answer of these two factors.
1.25 into 10 raising power minus 4 आ रहा है चेंज इन डायमीटर नहीं सर सॉरी एक मिनट मैं निकाल रहा हूँ
सर मेरे पास 2.12 into 10 power 10 आ रहा है.
2.12 10 power minus 4.
recheck. इतना change हो तो I don't think so.
So 2.12 10 power minus 4 आ रहा है.
Just be careful about the units.
सही यही है 2.125 into 10 raising power minus 4
For diameter, minus 4. I think
yes
minus
sir
4.
yes sir
Now calculate the change in length.
आ रहा है
For change in length, let me write the expression. That will be 1.2 is the pressure, the diameter is 1000 millimeter, then the thickness is 12 mm, modulus of elasticity is 200, but since it is in gigapascal, so let's multiply it with 1000 to have the same unit as the pressure, so they will cancel out. Then we have 1 minus 2 into 0.3, and the original length is multiply this whole expression by 3000 because the length is 3 meter. So if I convert this into millimeters, that will be 3000 mm. So what is change in length now?
1.5 into 10 power minus 4.
6 into 10 raising power minus 7
I have two different answers. 1.56. Anyone else?
so 6.1 minute 6 into 10 raising power minus 7 6 into 10 raising power minus 7 sir
Let me quickly see the answer. I don't have the exact answer for this one. So two to three students can try this one, and if you are getting this answer, then this is correct one. So what about change in volume? Calculate this one as well. This change in length is 1.5 into 10 minus 4, I believe.
Yes, sir. मेरे पास 1.5 है.
This is the correct answer, 1.5 into 10 raised to power minus 4. So just make this correction, everyone. Now give me the change in volume. And this change in length, the unit for this one will be I have written this answer you will get when you substitute everything in meters. But when you are substituting everything in millimeters, I have just calculated myself. The answer that we are getting is 0.15 mm.
यस सर ये मेरे साथ भी आ रहा है.
Yes, this is the correct answer in terms of millimeters. Now, in the same way, if I solve it for the diameter, I'm not sure if you have given me the right answers. For diameter in millimeter units, this answer is in meters, and in millimeters, the answer is 0.21 millimeters. So this is the answer for diameter, and this is for the length. And if you are getting way bigger answer, you should always cross-check your answer. So for change in volume, obviously the first thing that we need to calculate is this volumetric strain, that is, I will just write it over here, PD over 4TE into 5 minus 4 nu. So if I substitute everything, P is again 1.2.
सर हमने जो रिलेशन निकाला है चेंज इन वॉल्यूम के लिए वो हम लोग डायरेक्ट यूज कर सकते हैं ना सर.
What's the correlation?
Sir, change in volume is equal to pi by 4 into 2L d into sigma d plus d square into sigma L.
Yes, in fact, we have direct correlation. Yes, you can use this one. In fact, let's solve it by using this correlation. We don't have to report the strain. If you want to report the strain, then you should use this one. So if I use the direct correlation for change in volume, that is pi by 4 2LD delta D plus D square delta L. So what will be the volumetric strain using this one? Give me the answer. You have every factor with you, but be careful about the units.
सर 1.1 mm क्यूब
1.1. Anyone else? Let me just cross check this answer.
Sir, 1.1 times 4 minus 3 r.
सर 1.1 इन टेन पर -3 मीटर क्यूब आ रहा है, तो इसको मिलीमीटर क्यूब में कन्वर्ट करें।
The answer is, I think, 1.1 into 10 minus 6 millimeter cube. Anyone got this answer?
यस सर, ये सही है।
Yes.
2.1 ही आता है सर, ये सही है।
यस सर।
1.1 to 10 minus 6 millimeter cube. So this is the this is how you calculate. And even if you use this particular expression, which is written over here somewhere, this one for volumetric strain, you will get the same answer for this strain. So this is about the calculation of strains in the cylinder, and in the next class we will be starting with thick cylinder. And for the thick cylinder, the calculations are somewhat different compared to this one, but that is also not too much complex. There is some sort of complexity in the derivations, but the problems are somewhat similar to this one. So I will upload these lectures and you can go through them again, and if you find any difficulty, you can ask me anytime. So if there is any question, you can ask me now.
सोनी सर,
Yes.
सर मेरा एक क्वेश्चन था जो पीछे आपने अनसिमेट्रिकल बेंडिंग करवाई थी ना, उसके रिलेटेड है।
क्या क्वेश्चन?
सर मैंने आपको ना रात को 2 पिक्चर भी स्क्रीनशॉट भेजी थी, वो ज़रा ओपन कर लें 063 से सर, वो उसके अंदर है।
चलो मैं देख लेता हूँ, देख लो।
जी सर। सर क्वेश्चन ये था कि जब अनसिमेट्रिकल बेंडिंग के अंदर हम मूवमेंट के लिए जो है ना थीटा यूज़ करते हैं, वो आपने बोला था कि हॉरिजॉन्टल एक्सिस से, यानी कि जो हमारा प्रिंसिपल हॉरिजॉन्टल एक्सिस है ना, उससे लेके जो हमारा रिजल्टेंट मूवमेंट है ना, वहाँ तक का एंगल हमने यूज़ करना है।
ठीक है
सर आपने जो प्रॉब्लम नंबर 3 करवाई थी ना अनसिमेट्रिकल बेंडिंग के लिए, जिसमें टी सेक्शन था, सर उसमें आपने हॉरिजॉन्टल एंगल नहीं यूज़ किया होगा।
किसकी कैलकुलेशन में?
सर आपने प्रॉब्लम करवाई थी क्लास के अंदर।
नहीं, उसमें हम क्या कैलकुलेट कर रहे थे?
मूवमेंट सर, मूवमेंट कैलकुलेट कर रहे थे।
तो मूवमेंट कैलकुलेशन में आपको कौन सा एंगल चाहिए? उसमें तो आपको सिंपल मूवमेंट का एंगल चाहिए।
जी सर, मूवमेंट के लिए देखिए, मूवमेंट अलोंग टू जी एक्सिस और मूवमेंट अलोंग टू वाई एक्सिस के लिए हमें एंगल चाहिए होता है।
हाँ जी।
तो सर
आप वो फिगर दोबारा से खोलो और उसमें देखो कि आपको कौन सा एंगल चाहिए। 6000 का हॉरिजॉन्टल से एंगल चाहिए उसमें। तो अब इस थीटा को उस थीटा के साथ कंपेयर ना करो जो कि न्यूट्रल एक्सिस के लिए थीटा था।
सर हम लीव कर दें?
यस यू कैन लीव।
सर मिड का रिजल्ट कब तक आएगा?
क्या है?
सर मिड का रिजल्ट
मिड का रिजल्ट भी आ जाएगा। अच्छा, ये जिसका भी क्वेश्चन था, ये अपनी फिगर खोलो दोबारा।
सर मैंने खोली हुई है।
हाँ, इसमें अब इसमें ना इस थीटा को उसके साथ ना कंपेयर करो कि ये उस मूवमेंट का एंगल है। इधर आप क्या कर रहे हो, आपके पास एक रिजल्टेंट मूवमेंट आ गया हुआ है, ये 6000, ये जो मैंने ब्लू एरो से शो किया हुआ है, ठीक है। अब आपने इसको सिंपली रिजॉल्व करना है टू एक्सिस पे। एक इसको आपने एम जेड पे लेके जाना है और एक एम वाई पे, तो इसके दो कंपोनेंट्स क्या होंगे?
सर ये 6000 के लिए नहीं, मैं 1000 के लिए कह रहा हूँ, 1000 जिसमें दो लोग रगड़े थे।
1000 फोर्स है ना, 1000 का मूवमेंट क्या होगा?
जी सर, ये होगा एक साइन थीटा होगा और एक कोस थीटा के जो है ना।
1000 फोर्स है, आप मुझे पहले उसका मूवमेंट बताओ कि मूवमेंट मैक्सिमम मूवमेंट बीम में देख के बताओगे आप।
सर एक एक मिनट सर, एक मिनट।
हम्म,
जैसे सर 6000 होगा।
6000 होगा। अब वो 6000 शो किधर होगा?
जी सर।
6000 मैंने इस फिगर में शो कहाँ किया हुआ है?
तो ये फोर्थ क्वाड्रेंट में इन साइड शो होगा।
ये जो ब्लू एरो से किया हुआ है, राइट?
जी सर।
अब इस ब्लू एरोस का मैंने शो कर दिया, अब इसके दो रिजल्टेंट होंगे।
जी सर।
वो रिजल्टेंट होगा एक जेड एक्सिस पे, एक वाई एक्सिस पे।
जी सर।
अब वो रिजल्टेंट कैसे कैलकुलेट करोगे?
सर उसके लिए तो यही है ना कि एक दफ़ा उसके लिए एम जी के लिए साइन थीटा ले लेंगे और एम आई के लिए
हाँ,
कॉस थीटा ले लेंगे।
अब वो साइन का क्या एंगल बन रहा है?
ओके सर, अब ठीक हो गया।
ठीक है, इसको उस थीटा से नहीं कंफ्यूज करना, वो जो न्यूट्रल एक्सिस है, हर चीज के एंगल्स और कन्वेंशन डिफरेंट है, ठीक है।
जी सर। सर दूसरा क्वेश्चन ये था कि आपने जब मूवमेंट की डायरेक्शन लेते हैं ना, रिजल्टेंट मूवमेंट की डायरेक्शन लेते हैं कि ये आउटवर्ड आएगा कि
हम्म
टुवर्ड्स टुवर्ड्स द रीजन आएगा।
हम्म।
सर आपने जो रिएक्शन ज्यूम किया था ना, जिसकी वजह से ये मूवमेंट प्रोड्यूस हो रहा था, वो आपने कहा था कि लेफ्ट साइड से लेते हैं, ठीक है।
हाँ,
लेफ्ट साइड से आपने ज्यूम करके लिया था। अगर राइट साइड से लें तो ये तो फिर काउंटर क्लॉकवाइज बन जाता, तो फिर जो है ना
वो
मूवमेंट की
राइट साइड से भी आप ले सकते हो, तब भी बनेगा वही। अब वो राइट साइड से देखो, रेजिस्टिव मूवमेंट क्या होगा? मूवमेंट काउंटर
क्लॉकवाइज।
क्लॉक, रेजिस्टिव हुआ आपके पास,
क्लॉकवाइज।
क्लॉकवाइज हुआ। अब
जी
उसको
सर।
आपने फिर शो राइट साइड पे करना है। जिस तरह इधर मैंने बीम बनाई थी ना उस दिन एक सेंटर पे,
जी सर।
उसमें मैंने लेफ्ट साइड पे ये ब्लू एरो शो किया, उसका फिर एरो आपने राइट साइड पे शो करना है। इधर बीम बनाओ और राइट साइड पे शो करो, वो फिर भी आउटवर्ड ही जा रहा होगा,
ठीक है सर।
ठीक है।
जी सर, थैंक यू सर।
So, this is it. If there are no more questions, then we will meet tomorrow for BSA class. I will discuss if we have to change the time. If not, then it will be at the as per schedule. I believe it is at 9 a.m. So thank you for your time till then. Allah Hafiz and take care.